In this chapter we deal with oscillations, periodic motion, simple harmonic motion. What are the concepts involved? Periodic motion is motion which repeats itself at fixed intervals, while oscillatory motion is a special type of periodic motion involving to and fro movement around a central equilibrium point. All oscillatory motions are periodic, but not all periodic motions are oscillatory, example circular motion. Oscillatory motion is periodic movement around equilibrium point, for example the pendulum of a wall clock. Amplitude is maximum displacement from the equilibrium position of an object oscillating around the equilibrium position. Damped oscillation, the maximum positive displacement in positive and negative directions decreases as time progresses and eventually oscillation may stop. Critically damped condition, in which the damping of an oscillator causes it to return as quickly as possible to its equilibrium position without oscillating back and forth about this position. Elastic potential energy stored as a result of deformation of an elastic object, such as the stretching of a spring. Equilibrium position, where the spring is neither stretched nor compressed. Force constant, characteristic of a spring, which is defined as the ratio of the force applied to the spring to the displacement caused by the force. Simple harmonic motion, SHM, oscillatory motion in a system where the restoring force is proportional to the displacement, which acts in the direction opposite to the displacement. Frequency, number of repetitions per unit of time. Natural angular frequency of a system oscillating in SHM. Oscillation, single fluctuation of a quantity, or repeated and regular fluctuations of a quantity, between two extreme values around an equilibrium or average value. Overdamped condition, in which damping of an oscillator causes it to return to equilibrium without oscillating. Oscillator moves more slowly toward equilibrium than in the critically damped system. Period, time taken to complete one oscillation. Periodic motion, motion that repeats itself at regular time intervals. Phase shift angle, in radians, that is used in a cosine or sine function to shift the function left or right, used to match up the function with the initial conditions of data. Physical pendulum, any extended object that swings like a pendulum. Resonance, large amplitude oscillations in a system produced by a small amplitude driving force, which has a frequency equal to the natural frequency. Restoring force, force acting in opposition to the force caused by a deformation. Simple harmonic oscillator, oscillatory motion in a system where the restoring force is proportional to the displacement, which acts in the direction opposite to the displacement. Simple pendulum, point mass, called a pendulum bob, attached to a near massless string. Stable equilibrium point, point where the net force on a system is zero, but a small displacement of the mass will cause a restoring force that points toward the equilibrium point. Torsional pendulum, any suspended object that oscillates by twisting its suspension. Underdamped, condition in which damping of an oscillator causes the amplitude of oscillations of a damped harmonic oscillator to decrease over time, eventually approaching zero. In this chapter we have added 7 potential Z/NEET problems. We hope you find them useful.